Welcome to qnawire.
All right, we've got a molecule as follows. Let me do a little better job there. And we need to construct an NMR spectra for this. So I think the first thing we should do is identify the unique hydrogens, right? Let's call this hydrogen A, of which there will be 3. Hydrogens B, of which there will be 2. Hydrogens C, of which there will be 2. Okay. And do we have any remaining hydrogens? Well, there's the one that's on the alcohol, but that's already been placed for us. Okay. So we have the hydrogens that we need. We've got HA, of which there are 3. We've got HB, of which there are 2. And we've got HC, of which there are 2. Okay. Now we need to determine what sort of splitting pattern we might expect any of these hydrogens to have. Okay, for example, hydrogen B has 3 neighbors, right? Actually, let me rewrite how I'm going to put this. I'm going to say NH, right? Because that's what they're like. 1H is 1 proton, 2H is 3, etc. Okay. Okay, splitting patterns. Okay. So let's look at hydrogen A. How many neighbors does it have? Well, it has 2 equivalent neighbors, so we should expect it to be a triplet, right? This is going to be a triplet. Okay. Like so. Okay. Let's look at B. How many neighbors does B have? B has 3 neighbors. All 3 of hydrogen A's are its neighbor, and they're all equivalent, which means we should expect it to have a quartet. Right? All right. And finally, we've got C. Does C have any neighbors? No, no neighbors, right? There we are. Okay, now all we need to figure out is what the relative shift of any of these will be. I'll just say ppm. Okay, so for this, we want to just look at any old NMR chart, which shows us the relative shift of various protons based on their relationship to other functional groups. Okay. Well, for one, we can just kind of start out right away and say, well, A's only neighbor is another alkyl chain, meaning A won't have any sort of significant special shift, right? So if we've got a slot that's like, let's say it's 6, 5, 4, 3, 2, 1, 0, we should expect that A will be close to 1, right? So we're going to put that in this slot, right? And it's going to be a triplet, and it's going to be 3 protons. Okay. B, on the other hand, well, it's connected to an alkene, right? So here's where we want to refer to an NMR chart, or an NMR shift chart, right? So hydrogens that are on carbons that neighbor double bonds, right? What kind of shift should we expect for that? Basically, is what we're looking for. And typically, that's in the 1.5 to 2.5 range, right? That is being on a carbon that's neighboring a double bond puts you around 2.5, right? So it seems very likely that B, our quartet of 2 hydrogens. Right. We'll be right there. Okay. And then finally, we've got C. Now, this is on a carbon which neighbors an oxygen, right? So you could call it like a ether proton. And that's usually going to put you somewhere between 3 and 4, okay? And what I mean by that is, we're neighboring this oxygen, right? That's electron withdrawing. It's going to de-shield these, shift them upfield, okay? So anyway, here we go. C should be here. C is 2 protons, and we said C is a singlet.